How many 4-person committees can be formed out of a class of 16 students? So what they're saying in this question is there's 16 students and we want to pick 4 to be on a committee. Maybe they're some kind of academic committee. So 16 students, and we're going to pick 4 to be on an academic committee. How many different ways are there to do that? How many different committees can be chosen? So in other words, let's lay out 16 students. We're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we have these 16. You don't need to number them, but I'm just going to do it to be thorough. We're going to have these 16 different students, and we're going to pick some of them to be on the committee. So basically, this problem, I'm solving this different than Math Excel does. I'm going to say, I'm going to pick this student, this student, this student, and that student to be on the committee. And the other ones are not on the committee. They're no's. That's one way I could pick 4 students to be on a committee. Now let's do it again. I could say, okay, I'm going to choose student 1, student 7, students 15 and 16 will be on the committee, and therefore all the other students are not on the committee. So there's a second way. Is this making sense? So we're picking different ways. So this is one way to pick a committee. It would have students 4, 9, 11, and 13. Here's another way to pick a committee that had student 1, 7, 15, and 16 on the committee. So this is the second way. And on you go. We want to know how many different ways are there to do this. How many different committees can you pick? How many different ways are there to pick 4 students out of the 16 to be on the committee? Well, basically, it's asking how many ways are there to arrange those letters. How many ways to arrange these 16 letters where we have 4 C's and what's that going to be? 12 N's. 4 C's and 12 N's. Well, we learned that previously. Remember the formula for arranging letters where you've got repeats? It's always n factorial over n1 factorial, n2 factorial, etc. Down here are the repeats. And up here is the total number of letters. So that's the formula. Total number of letters on the top, in factorial, and the repeats down below. So this is going to equal total number of letters, 16 factorial, 16 letters altogether. And there's 4 C's, 4 factorial, 12 N's. Those are repeats, right? 4 C's are repeated, 12 N's are repeated. You could switch these order. It doesn't matter what order you put them in. Either way is fine. And now let's work that out. So to work this out, it's going to be 16, 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. I don't care about the 1. On the bottom, 4, 3, 2, 1, and 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. And do you see how we can do this easily? The 12 on down to 1, 12 on down to 1 cancel, don't they? So then you just multiply out the rest on the top. You just use your calculator now. Here, I'll bring it down here. Take 16 times 15 times 14 times 13. And then you can just divide by each of the numbers on the bottom. Divide by 4, divide by 3, divide by 2. You don't need to do the 1. It doesn't matter. You could figure all these out in advance, 12, 20, 24, and then just divide by 24. Or you could just divide by them one at a time. It'll work the same either way. Let's do it. And I'm getting 1820. There's 1,820 different ways you could choose 4 of those students, of those 16 students, to be on a committee. 1820. So there we go.